So we can take some questions now.
Gladly.
I think we've got some microphones. Here they come in the back of the room, and if you want to step up to a microphone and
Gladly.
take it from there. Okay.
I tired you all out, no questions. I had to go over. It was Pluto's fault, not mine. Pluto took 15 minutes away from me.
How about the inclination of 17 degrees that Pluto exhibits?
Yeah, why? That's a good question. All of the dwarf planets have that kind of inclination. Eris is even stranger. I think it's like 60 degrees. So again, what, did it happen? We like to always explain things with collisions. If it doesn't fit the nice little model, oh, it collided. The whole idea of Uranus being on its side, it probably collided when it was formed. It started out this way, but something else came in and knocked it over. Venus is clockwise rotating around its axis. So in effect, like we have a 23-degree tilt from being perpendicular to the ecliptic. Venus is about 180 degrees. Well, Venus is much smaller than Uranus. It got collided, it got totally knocked over. So in astronomy, when something is off norm, collision. When in doubt, or turbulence. Yes?
If it was knocked off in a collision, which started it rotating, why wouldn't it just keep on rotating?
You know, the celestial mechanics and rotational instability is really incredible because even the rings have gone with it. I just finished teaching a summer session in physics, and I was teaching angular momentum. Angular momentum, if you remember Chuck Norris, perfected the kick. If you really want power, you don't just hit somebody. You rotate first and then smack them. Sort of. And that rotational, that angular momentum, that torque that you can get from things rotating can stabilize the system even though it's being torqued. Does that make sense? No. Sort of. And we also don't know when it got knocked over.
Yeah.
During its...
I was wondering if the thought is it's slowly still continuing to rotate?
Oh, it's still rotating. It rotates about 10 on its axis. It rotates about,
No, I mean the axis.
it probably wobbles a little bit, but I don't think so. I think it's reached the stability thing. No, it's not changing.
Okay.
Yeah, that's the one thing, as I understand it, it was, it's in a stable position of sorts.
Hi, we want to make sure to get your questions on our video, so if you could come to the mics to ask your questions, that'd be great.
Yeah.
2 mics, no waiting.
Or talk loud. No more? I answered all your questions. Oh, good.
I've got one more, and one is I assume the planetoids, planetesimals, I guess it is, came from the dust. Somehow the dust
Yes, they formed too, yeah. Okay. Everything came from those little dust guys, which came from atoms. Right. Yeah. So, yes.
I guess that feeds into my question, but in your models, if you're talking about things expanding and collapsing and colliding all the time, are you seeing a model where there's new nebula forming all the time, and so there's this kind of perpetual creation explosion, or are we still talking Big Bang dust that's...
That is an excellent question. Excellent question. There's hundreds of stars that come from those nebula. And you know what feeds the nebula? Stars going through their evolution, exploding, and putting it out there. And so it's a cycle. It's a cycle. And planets just come from that. Now, you'll get a planet forming from a nebula that has a lot of atoms. If the nebula is hydrogen and helium, you're not going to get rock. So you have to wait until a star evolves, makes those rocks, makes the silicon, makes the nitrogen, makes the oxygen, and then you could start getting interesting things that happen. And it all starts out with an atom. Yeah, it's crazy. Yes?
What's the current views about the formation of the moon? It seems to be a rather peculiar object, isn't it?
Yeah, the moon probably came from a collision. An object hit the Earth and threw material off of the moon, off of the Earth. but it didn't have an escape velocity, couldn't leave Earth's gravitational pull, so it went into orbit around the Earth. And then it did the accretion thing. As it was going around and around, it just accreted and formed. And when the Apollo astronauts brought back rock and showed that the composition of those rocks are very similar to the rocks that we have on Earth, that kind of confirmed that the moon did come. Whereas like Mars has two moons, Phobos and Deimos. They're probably caught from, they're probably asteroids that escaped from the asteroid belt, and Mars caught it. Yeah. Yes?
So how do you arrive at a model? What is the process by which you start with a pile of data and you say, we have these parameters?
Oh, that's so much
we
fun.
are constrained.
No, it goes even more. That
Please elaborate on the fun.
Oh, it is so much fun, because what you do is you take those differential equations that you hated in college, and those differential equations are the mass conservation, energy transport, okay, just flip that, equation of state, how energy gets through the chemistry of it, and you put that all into difference equations, and you build your model, and that's a numerical model, and you just start off with an initial condition. You say, okay, at t equal to 0, this is the temperature, this is the size of what you're starting, and you let the computer compute. Now, you don't do it blindly. I mean, I just sat there for many years looking at it, making sure it would have a problem. We'd have to fix the physics. But the nice part about it is that we can make Jupiter in maybe, 3 weeks. And we'll change we could change how much material there is, how much solid material there is in what part of Jupiter. And so we change the parameters. We change the size of planetesimals that it hits. Right now, the models are such that we've connected it to a nebula. So the nebula is evolving at the same time that the planet is evolving. And so there's all kinds of fun with that. It really is a lot of fun. And then you have all these data, then you print them up, and then you make cool movies. And then you come and tell people about how much fun it is. Yes?
Is it critical that the cloud is dusty, or could
Yes.
a star form from a clean cloud?
A star can form from clean clouds, and they did. At the beginning of the Big Bang, all we had was hydrogen and helium, basically, and stars formed. They were huge stars, 300 massive, which was good because big stars go through their evolution fast. And the important part for stars to evolve is that stars are stars because they fuse. They have fusion reactions at their core. It's hot enough to have fusion reactions. So the very first things that hydrogen fuses is into helium. And then helium will fuse into carbon. And carbon can fuse into oxygen and nitrogen. I mean, all of us, star stuff. Anybody have gold on them? That gold was made in a star during a nova, during a supernova. That was an atom that was thrown out during a supernova, and it met up with another atom. And that atom got a third atom, and that third atom told another one. And then what happened is they just kept, and then they formed into grains. And those grains eventually formed into planetesimals, and the planetesimals formed into Earth. And then from Earth, we were able to evolve and send miners down into the caves and get the gold. That started out. Yeah.
The elements in the surface of Pluto seem a lot like the atmosphere of Earth, and you're saying water, and is there any relation between the water on Pluto and where it came from, and where did the water on Earth come from? And is Earth losing any water does this stuff ever get driven off?
No, yes, and no, and yes. There's water everywhere. I mean, you have hydrogen, you have oxygen. I mean, our whole solar system has silicon and nitrogen, and it's just how they combine. And how they combine depends on the temperature and the pressure and the environment of what's out there. So the basic elements there's carbon, oxygen, nitrogen, hydrogen, then there's silicon, magnesium, I forgot the other, there's about 19 of them. And if you look at any geology or any meteorology, atmospheric gas, there's some form of those atoms in there. But it's, water in this room compared to water in our freezer is different as water on Pluto. Now, water on Pluto, remember, it's small pressure as well as very cold. And atoms do weird things at different temperatures and pressure. I forgot which it was. I was listening to on one of the blogs there that under certain conditions, I forgot what, I think it might be methane, it goes from one kind of solid form as compared to another kind of solid form. And it switches from crystal form that could be square to a circular crystal form, just depending on the temperature and pressure. Same elements, and then they'll do different things. Material sciences are really very interesting that way. So even though there's water on Pluto, it might be different in different shape, in condition than it is on Europa, one of the moons of Jupiter.
You were saying that the atmosphere around Pluto is sublimating from
Yes.
presumably the surface.
Yeah.
And so, I mean, if it's doing that, why doesn't it go any further or just go off into
Well,
space?
remember, things are moving. They have a velocity. Now, everything needs an escape velocity to get off. So if that atom is not moving fast enough, it's stuck on Pluto. It's got to have an escape velocity to leave Pluto's gravitational hold on it.
But wouldn't something like solar wind or something, wouldn't that
Okay. Could it help along?
interact with those?
Actually, they were thinking that they see that Pluto is a lot redder than they expected. And in fact, you hit on it. They think that it's the solar radiation that's interacting with the surface that's doing something to the surface structure to make it a lot redder than they thought. You're absolutely right.
Or I mean, if it went one way and it's frozen, why is it going the other way?
Well, you got to put energy in to melt it, and you have to have enough energy to melt it. So the sublimation, just to give another visual, is we've all experienced sublimation with dry ice. Carbon dioxide under room temperature and pressure will go from solid to gas. There's never been liquid carbon dioxide. Well, under pressures that are at Pluto, that's what will happen with some of the solid gases there. They will go from solid ammonia, solid methane, solid water into gas, and that's where they think that atmosphere comes from.
Isn't a lot of the water on Earth coming up in volcanoes and things? I mean, is more water being produced yet from?
And no, it's kind of circulatory between the oceans. The Earth's surface communicates more with our atmosphere than it does from volcanoes. I don't think the volcanoes bring up too much water. I think it's more the ocean and the atmosphere, what's stored in the atmosphere. And it's a cycle.
A lot of steam comes up from
Yeah, so it goes into the atmosphere and then rains out eventually. But the steam not necessarily is H2O. It could be other. I mean, most of the deaths on volcano come from asphyxiation. There's sulfur gas. So I don't know if it's steam or is it sulfur, other kind of gaseous outflows.
And you're saying that, well, so it doesn't, the water's trapped on Earth then too?
Well, lately the conversation is yeah, the water's trapped. And there is a lot of water way deep down on Earth, but we can't tap into it. Okay, sorry.
So I think there's a second way that planets could possibly be formed besides accretion, or maybe I'm not up to date on this, but when a supernova explodes,
Yeah.
The only thing that can be at its core, as I understand it, is iron.
Right.
Anything that's more massive than iron in terms of its molecular structure is formed in the explosion.
Correct.
And then As I also understand it, sometimes the core of a supernova, which has had a lot of iron and perhaps silicon.
There's silicon, but that goes into the supernova cloud.
Right, but the core of the supernova is sometimes expelled out into
The core of a
Into the ambience.
the core of the star that goes supernova usually implodes.
Right.
And what happens is when it implodes, it either becomes a neutron star, so all those electrons go get pushed into the nucleus, protons, and it just all turns into neutrons. And or if it's a lot more massive, it creates the creature that creates the black hole.
Okay.
So those are pretty much the two outcomes. All the other elements on the periodic table, because up until iron, everything is is formed during the fusion process. After the supernova, what happens is you have fusion reactions and as well as fission reactions. So the rest of the periodic table is made during that time.
So my theory that Earth might be the remnant of a supernova because of the density of its core is probably not possible, because supernovas, as I understand you just said it, either the core either becomes a black hole or a neutron star.
Right. Yeah, supernovas, the job of a supernova is to circulate and make more material for other stars to form so that those stars can collapse, form a protoplanetary disk, and make more planets.
But the Earth has at its core probably a lot of uranium or other radioactive.
It has everything that was in the nebula.
Because there's like a nuclear reactor at the core of Earth that keeps it warmer than it would be at this distance from its small
Well, I
star.
wouldn't call it a nuclear reactor. There's just natural radiation, because we have all those elements, and that does keep it warm. We have iron and nickel and metals at the core. You're right. And Earth's core is liquid and solid. And so, yeah, and that came from stars. That all did come from stars. But it came from the stars by way of the nebula, not by way of a supernova.
So it's not possible that the sun could have captured the remnant of a supernova and have it in orbit, because Earth is at the same plane as all of its neighbors like Saturn.
It's the ice skater thing. It's the conservation of angular momentum, because as this gas is collapsing, so what's happening is it's also flattening, and it just keeps going around and around and around unless there's something else to collide it with. Now, there's a whole thing with binary stars. That changes things, but that's another hour, and I don't know about you, but I'm done.
Thank you all, and looking forward to seeing you at Hannah House in September.
Okay, thanks.